as we're headed into 8.6, we're actually going to start into factoring. And as we talk about factoring, here, let me grab this real quick. As we talk about factoring, we're going to start in with the very basics of greatest common factor. Greatest common factor is like the largest item that we can divide out. So it's kind of like when we reduce fractions, we want to find the greatest common factor. What's the largest number they can both be divided by? So that's what the greatest common factor is. It's actually the largest value the multiple items or multiple terms. I'll tell you that multiple terms can be divided by equally. So in essence, we're reducing them. So if I had like 8 over 24, the greatest common factor between 8 and 24 would be 8, because I could divide this by 8 and get 1, divide this by 8, and I would get 3. So I could reduce to 1/3. So how do we find that though? So if I have terms, I'm going to use factors of the terms and see what they have in common. And then I multiply those back together. But exponents, you're going to use the lowest degree. Use the lowest degree of each variable. So here we go. We're going to talk about like 16 and 24. Well, 16, if I'm going to use the factors of the terms, so here's one term and there's the 24 is the other term. So 16 would be broken down into 8 times 2. Well, 8 breaks down to 4 times 2. Bring down this other 2. And 4 breaks down to 2 times 2 times 2 times 2. Just bring these guys down. So my factors are, for 16, is 2 times 2 times 2 times 2. Now 24, let's use purple. 24 can be broken down to 12 and 2. And 12 can be broken down to 6 and 2. Bring down that 2. 6 can be broken down to 3 times 2. Bring down that 2. Bring down that 2. So now I'm back down to the prime factorization. You guys have done prime factorization for a long time. It's been a while though. So looking at the prime factorizations, I want to see what is the greatest common factor. Now I'm going to go through here and say, well, this one has 1, 2, 3 2's, and this has 1, 2, 3 2's. So they both have 3 2's in common. So both have 2 times 2 times 2, which is 8, in common. So 8 is the greatest common factor. All right, so if I look over here at 45 and 60, 45 can be broken down to 9 times 5, and 9 is 3 times 3. Bring down that 5. 60 can be broken down to 6 and 10, which would be 2 and 3, and 10 breaks down to 2 times 5. So now if I'm looking for what they have in common, I'm going to start with, first of all, 2's. So there's 2's here, but there are no 2's here. I have a 3 here and I have a 3 here. I have 2 of them, but I only do 1 for 1. So we have a 3 in common. And then I have a 5 in common. They both have a 5. So 3 times 5, they both have a 3 and a 5 in common, which would be 15 is my GCF. So both have a 3 and a 5. So 3 times 5 gives me 15. So 45 divided by 15, yep, and 60 divided by 15, yes. Okay, now I'm getting down to those exponents with the variables. So my variables, again, I'm going to use the lowest degree of each variable. So my lowest degree of my x, I've got x to the fourth and x to the sixth. So I'm going to use x to the fourth. And here I'm looking at it again. I'm going to use here's my m and m. My lowest degree of m is m to the fifth. And then I'm looking at my n's, and my lowest degree, this is a 1, so it's just going to be an n, or n to the first. That would be my GCF. Now we're going to get into a quick review. We know the distributive property. So the distributive property, we know that we're going to take the outside number and we multiply it by each of the inside numbers. So we end up with 3 times x, and 3 times 5 is 15. And we know 2 times x is 2x, and we know 2 times negative 3 is negative 6. We know that 5 times 2x is 10x, and we know that 5 times 7 is positive 35. 6 times 3x is 18x, and 6 times negative 4 is negative 24. So now what we're going to do is we're going to go in reverse, okay? So we're going to go in reverse, we're going to actually divide out that leading coefficient, or that leading term, that greatest common factor. So between a 3x and a 15, my greatest common factor is in fact 3. So if we look back at what we just did, we're going to take out a 3, and to show that, we're going to divide each term by 3 and reduce each fraction. So it's going to be 3, and then I'm going to end up with x plus 5, because 3x divided by 3 is just x, and 15 divided by 3 is 5. Same thing on this next one. I'm going to divide out a 2. So I divide both items by 2, and I get 2 parentheses x. Negative 6 divided by 2 is negative 3. So we're kind of dancing. We went forward, we distributed, and now we're going to take it back. Okay? So giveth and taketh away. So this next one, I've got a 10 and a 35. Okay, well, I can't take a 10 out of both, but 10 breaks down to 5 and 2. I could take a 5 out of both of them. So 5, and I'm going to divide both of them by a 5. And so I end up with 5 on the outside. 10 divided by 5 is 2, and 35 divided by 5 is 7. And this last one, we know it's going to be a 6 just because I'm telling you, and we're just doing the exact problems backwards. However, 18 and 24, I'm going to use the 18, and I'm going to say 18 would be 9 times 2. Well, 9 doesn't go to 24. I could say it is 3 times 3 times 2. Well, 2, yes. 3, yes. But about 2 times 3, which would be 6 times 3. 18 divided by 6, and 24 divided by 6. So I'm going to have 6 on the outside. 18 divided by 6 is 3x. And negative 24 divided by 6 is negative 4. It really, really helps if you know your multiplication tables at this point. I think I've kind of told you that from pre-algebra to algebra, the start of it. We have to know how to multiply. All right, so this next part I want you to try a little bit, and then we're going to kind of go through them. So try them a little bit on your own, what you think you could divide. Just kind of go like, just do a quick little, what you think you can divide out, put it out here. What do you think you can divide out? Put it out here. I'm looking at my terms, okay? So the first one, I've got a 5 and a 10. Well, I can take out a 5 because 10 divided by 5 works, so 5. So I can divide all of them by 5. And then my lowest value of x, which is x to the first power, so it's just going to be an x, 5x. So when I'm done, I'm going to have 5x on the outside. 5 divided by 5 is 1. X squared divided by x gives me just an x, so x. Plus 10 divided by 5 is 2. X divided by x is nothing, it's gone. So and these cancel. So I'm just left on the inside with an x plus 2. If I were to distribute it back out, I would get with what I started with. All right, the next one, I've got 5p7 to the 7th power and negative 6p squared. Well, I've got a 5 and a 6. There's nothing I can take out of there other than a 1, so I don't have to take a number. But my variables, they both have p's, and the lowest value is the p squared. So we're going to take out a p squared. So now I'm going to be left with p squared. If I divide this, I end up with a 5. P to the 7th over p to the 2nd. Where do you have more? Top by how many? 5. So p to the 5th. Minus, that 6 comes on down. And then p squared and p squared cancel. And I'm done. This next set, I've got an 8, a 10, and a 14. Well, 8 breaks down to 4 and 2. So I really have 4 and 2, or 2, 2, and 2, right? So 4 and 2. 8 can be divided by 4 and a 2, but 10 can't be divided by 4, and 14 can't be divided by 4. So we're going to take out a 2. Because they're both all 3 divisible by 2. Now my lowest value of x is just 1, because power of 1, so just an x. So we're going to take out a 2x from each of these. So basically we're finding out what was distributed originally. So I'm going to have on the outside the 2x, and then divide each of those terms. So 8 divided by 2 is 4. X cubed divided by x to the first 2 more on top, so x squared, plus 10 divided by 2 is 5. X and x, or x squared and x, 1 more on top, minus 14 divided by 2 is 7, and my x's are going to cancel. Done. And the last one of this kind, I've got 14, a 10, and a 35. Well, 14, 10 is my lowest number, so 5 and 2. 35 can go by 5, but not 2. 14 can go by 2, but not 5. So I can't take any numbers out. But I can take out variables. I've got x to the 3rd, x, and x. So I could take out an x. I've got y to the 6th, y to the 2nd, and just a y. So if I take out the lowest value of each, it's just an x, y. And now what I have left over, I've got on the outside x, y. I've got a 14. I've got 3 and 1, so I've got 2 more on top. This is 6 and this is 1, so I've got 5 more on top, plus 10. My x's cancel. I have 1 extra y on top, minus 35, and my x's cancel and my y's cancel. Done. All right, so the next part I want you to try on your own. So pause me, try it on your own. And afterwards, you need to do the checkpoint number 14. It is in the Google Classroom. It's an assignment. You can do it as many times as you want to get 80%. But let's go ahead and try these last 3. Try them on your own, and then we'll check them, and then do your checkpoint 14. Make sure you do your notes. So snip, notes, and results of quizzes for checkpoint. So this first one, I'm looking at a 4 and a 20, so I'm looking at the 4. 20 is divisible by 4, so we're going to take out a 4. There's not an x in both, so not the x. So divide by 4, divide by 4. So we're going to have 4 on the outside. X squared plus 20 divided by 4 is 5. The next one, I've got 21x to the 5th minus 9x squared. Number-wise, I think I can do 9. 9 can't go in 21, but 9 is 3 and 3. So I could take out a 3, and then my lowest value of x is x squared, so x squared. So take out a 3x squared, take out a 3x squared. So now I have 3x squared times 21 divided by 3 is 7. I've got x to the 5th and x to the 2nd, which is going to give me x to the 3rd left over, minus 9 divided by 3 is 3, and the x squareds cancel. Done. And the last one, this one's a little bit long, but we're going to look at 15. First of all, does 15 go into 45 and into 60? The answer is yes. So I'm going to use 15. Now we need to worry about your variables. I want my lowest value of x's and y's. So 7, 3, 2. So x squared. I need to move this over just a tad. And then y to the third, it looks like. So with that being said, I'm going to say x squared y third, x squared y third, x squared y third. Now, as we're going to rewrite this, I've got 15x squared y to the third. Now reduce each fraction. So 15 divided by 15 is 1. I've got x to the fifth left over here, and I've got y to the fifth left over here, because you have 5 more on top. Minus 45 divided by 15 is 3, so it's going to be negative 3. And then x's, I've got 1 more on top. Y's, I've got 3 more on top. Minus, and 60 divided by 15 is 4. And my x's cancel and my y's cancel. All right, so now you're ready to snip and clip the notes part of this and also do your checkpoint in the Google Classroom. So it's checkpoint number 14.